Okay, so we are recording. Let me get to the right stuff. No, calc. And let's go to. All right, so unit 4, we're going to look at problem number 10 first. Okay, so there it is. You'll notice that as we're going through the review, remember, still answer me. I'm going to ask a lot of questions in the chat because I'm going to help you through the review. I'm not going to just do the problems for you. Make sure that I've totally lost what I was going to say. Never mind, I guess. Okay. Oh, Erica wants 15 and 14, so I will add that to the list. 15 and 14. Okay. So that's the order I'm doing things. I'm looking at number 10. Okay. So let f be a function defined by f of x equals x cubed, or cubed root of x. What is the approximation for f of 10 found by using line tangent to the graph of the point at f at 8, 2? Okay. All right. So if I am going, I obviously need to do a tangent line approximation, right? What two things do we need to write the equation of a tangent line? Can you tell me that in the chat? What two things do I need? Okay, nice job, everybody. We need a point and we need a slope, okay? The good news is I have point. How am I going to get slope? So how do I get slope? Tell me that in the chat. How do we get slope? All right, nice job. We got to do derivative. So I am going to rewrite this as x to the 1/3. I'm going to go ahead and take its derivative, which would be 1/3 x. I'm subtracting 3/3, which is going to be negative 2/3. Okay. And then I'm going to rewrite this really as 1/3x to the 2/3 power. All right, and then I'm going to plug in the 8 because we're using the point 82 as the estimate for f of 10. So I am going to find f prime of 8. Interesting number, isn't it? 1/3, 8 to the 2/3 power. Now you'll notice, oh, I know what I was going to talk about. I was going to talk about calculator. Technically, it's open note, open calculator, right? But on this problem, it's not going to grade it in decimal point, probably, okay? So you want to make sure you're doing exact values, and I wouldn't use a calculator unless it really says to, okay? So we're going to do this without a calculator, and I totally should have written this over here. Is there another name for 8? What's another name for 8? Maybe written it with some exponents instead of the way it looks. Just like I can write 2 squared is the same as 4, right? It's another name for 4. So is there another name for 8 that has some exponents? What do you think? Ah, nice, 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 nice. 2 cubed. And that's important because check out what happens. These guys cancel. Isn't that nice? Feels good to cancel things, doesn't it? 3 times 2 squared. And we've got 4. So 1/12. So I've got the point. I've got the slope. I'm ready to write the equation of a tangent line, right? And then I've got to use that to estimate 10. So my equation of my tangent line, y minus the y value, which was a 2, equals my slope 1/12 times x minus 8. Now, technically, we should probably turn this into an f. So I'm going to be kind of cheat on this, and I'm going to call it f of x instead of y. Yeah, I'm going to have to move that 2 to the other side at some point. So I'm going to probably move it at the same time I'm plugging things in. So I'm going to do f of 10. I'm going to add the 2 to the other side. And then we're going to plug in the 10 all at the same time. And this is nice, right? This isn't a calculator necessary problem. Let's see, 10 minus 8 would be 2. 2 goes into 12 6 times. And then I need a denominator of 6, which is going to make it 12/6 or 13/6 as the answer. And again, I do not want the decimal point answer. I want the fraction, okay? really what I've done here is it's used to be a multiple choice problem. Okay, I took away the multiple choice. So we're going to look for exact values on these. Okay, which just means don't use decimal. All right, I got 10 done. Let's do 13. That's like infinitely faster than the second period's first problem. Theirs took like 20 minutes to do their first one. All right, so notice it says graphing calculator right there. So I'm going to use the power of my calculator to help me do this problem. Okay. So the height of the object at time t is greater than or equal to 1 is given by h of t equals t squared minus 16 over t plus 15. What is the velocity of the object at time t equals 3? Okay. So what am I given? Am I given the position, the velocity, or the acceleration right now? Which one do I have? Tell me in the chat. Position, velocity, acceleration. You can abbreviate. You don't have to use the whole word. All right. Awesome. Great understanding that we have position, right? This is the position function. We need to find the velocity. So what calculus do I need to do to get from position to velocity? Can you tell me that in the chat? What calculus do I need to do to get? We're fast on that one. Did you guys anticipate that was the question I was going to ask? Because that was really quick. Really quick. All right, so I need to take the derivative. But I have the power of my graphing calculator on this one. So, yes, I do. Okay, I'm looking at where I stole it from, and yes, we have the calculator. So let's put it in the calculator. Let's practice that. All right, because maybe I give you something crazier tomorrow, right, that we can't do by hand. So I'm going to doc B whatever's in my calculator. And I'm going to type this function in. So instead of t's, I'm going to type in an x. So x squared. Your calculator won't like t's. Minus, and then I'm going to do a control divide. And then 16 on the top, and x on the bottom. Oh, I just did that. I was doing this earlier today. It was driving me bananas. What happened? I totally lost my f even. Okay, so x squared minus control divide 16 over x plus 15. Don't care what it looks like. Okay. I'm going to come back to my calculator page. There's actually a couple ways to do it. So I'm going to come back to my calculator page. I'm going to use it from here. And I'm going to go Menu, Calculus, Numerical Derivative at a point. And then we're going to put in the 3. And hit OK. So it was Menu, Calculus, Numerical Derivative at a point. I'm going to click OK. And then I'm going to go to var f1 of x and hit enter. So 70 over 9. This one, because it was a calculator, it is going to be a decimal point. So if it's a calculator problem, decimal answer. Non-calculator problem, doesn't have the calculator, but you want the fraction or an exact value of some kind. So the way I get instead of saying just enter, I should do control enter. Let's see if it works. There we go. And it does it again, and it gives it to me in decimal. So it should have been 7.7777. It might be 778. I may have rounded. So try 7.777 or 7.778. I would take both on the test. I may have only put one of them in on the review. Okay. All right. We've already done 16. Somebody asked for 16. Okay, so 16 is in video, so I'm not going to go through 16 right now. If we have time at the end and you want me to do it live with you, I can, but let's try to get videoed as much as we can, okay? So I'm going to skip 16 in lieu of 17, okay, because 16 is like a 20-minute problem. All right, 17. So 17 says that we have a graph there, and it's g of x, and we're supposed to find the limit as x is approaching 1 of some craziness there. So the first, whenever I see a limit, what's the first thing that I'm supposed to do? What do I have to try no matter what? When I have a limit. What do you guys think? What's instinct at first telling you to do? And remember, I can't apply any rules till I do something else first. Plug the limit into the top and the bottom, solve separately. Good, Marilyn, okay. Sean, we're not there yet. We got to do something else first, okay? All right. Find the numerator. Okay, so we kind of know what's going on, but before I do anything, I have to plug that 1 in, okay? So let's plug the 1 in first. We know that on this test, there's going to be L'Hopital's rule, right? If I was going to be mean about it, I'd put a non-L'Hopital's rule problem on, right? I'm going to not be mean, okay? But you need to show me that you understand the steps that we have to accomplish. The AP test, you won't know. You have to do this, okay? So the limit as x approaches 1 of g of 1 squared, something doesn't seem right, does it? Maybe it's not a L'Hopital's rule. No, it's a L'Hopital's rule. 1 squared, oh, I see why. Okay, 1 squared plus 1. So that's going to be g of 2, right? Because 1 squared is 1, 1 plus 1 is 2. So I'm going to go to g of 2, and what do you know? It's equal to 0. Surprise, surprise, right? And then I'm going to go the limit as x approaches 1 of 4 sine of 1 minus 1. 4 sine of 0. So look at this. They're getting you to review your unit circle, okay? All right, so sine of 0 is what? If I pull out my good old unit circle. So what's sine of 0? Nice, it's 0. So I have 4 times 0 or just 0. The other one you got to watch out for, okay, that you should know, remember, is the natural log of 1 is also 0. That's a really good one for them to pull out here, okay? Somehow getting 1 in there and then getting a 0, okay? All right, so when I have 0 over 0, what's the special name for that form? Can anybody guess? What does anybody remember it? What's the special name for that form? Not applying L'Hopital yet. There we go. There we go. Indeterminate. Nice job. Nice job. Nice job. Okay, so indeterminate form, and now we apply L'Hopital's rule, which you guys told me earlier means I take the derivative of the top and the derivative of the bottom. Okay. Uh-oh. Check out the top here. Do I have a rule I need to be worried about? Oh, yeah, there is a little chain rule in there, isn't there? I pretty much guarantee somewhere in the test, you're going to probably see a product rule hidden somewhere, okay? You might see a chain rule hidden somewhere in the progress check, because you still got to know it, okay? In the progress check, there's one that has a chain hidden in a product. I'm not going to be that mean, okay? But there's probably going to be something somewhere, okay? I want to make sure you're testing and you're practicing and test at the level of the AP test, right? So we got to keep recognizing those things. Now, this isn't that hard of a chain rule, right? This one isn't that big of a deal. It's not like I'm not going to put 2 giant algebraic expressions together or other craziness like that and make you do a chain rule on it, okay? It will be something somewhat simple. All right, so my u, for lack of any place better, I'm just going to put it up here, is going to be x squared plus 1. So u prime equals 2x. And then my g, I'm just going to call it y equals. So y equals g of u. So y prime equals g prime of u times 2x. And then this is going to be g prime of x squared plus 1 times 2x. Or I could write it as 2x times g prime of x squared plus 1. Okay, now let's do the derivative of the denominator. Technically, I have a chain rule there, but watch this. So u is equal to x minus 1, so u prime is equal to 1. It's not going to matter, so I'm going to skip my chain rule there because my derivative is 1. That is the one and only time you can skip the chain rule, okay? All right, help me out. What's the derivative of sine? Because look, that's in there too, right? You have to still know that. Cosine, just like you've still got to know the derivative of e to the x, like you've still got to know the derivative of natural log. Got to know all those things. And again, it's better to know them. You guys are pretty quick at that, so I'm assuming you have it memorized. Okay, it's better to know them than to look them up, but you can have a page if you get lost to look up. All right, I am going to go ahead and plug in. Again, if you're not noticing, getting a whatchamacallit in the denominator here, something doesn't seem right again. I put a +1 and it is supposed to be a -1, isn't it? Okay, that's better because I had a minus over here. So I wrote it was a typo or a righto, and Erica caught it. Thank you. Okay, so if I'm not noticing that my denominator is going to 0, I can plug in and not have to do the 2 separate lines. If I'm noticing it going to 0, the safe thing to do is to write it separately. All right, so I've got 2 times 1 times g prime of 1 squared plus 1 over 4 times the cosine of 1 minus 1. All right, so I'm seeing g prime of 2 over 4 cosine of 0. All right, what's the cosine of 0? What's the cosine of 0? I need to close the door. Somebody has decided to skip his nap today, I think. All right, you are all correct that it is 1. Good. And then 2. All right, g prime of 2. Where am I going to look on my graph? Because the only thing I have is the graph. Where am I going to look on my graph for g prime? What am I going to have to look at? All right, nice job. We're going to have to look at the slope at 2. So I'm going to go to 2. I'm going to count the slope. It looks like it's down 1 over 1. So it looks like it's going to be -1. So it appears as though my final answer here is -2. All right, we got 17 down. We're just rolling right along. What about the 4? Oh, I'm wrong. Thank you, Marilyn. What was I thinking? It's not 2. 4, which should be -1/2. Thank you for catching that. Now we're correct. All right, let's look at 18. And we went from one with a graph to now one has a table. I would highly recommend, because I've written some of the tests, okay? I highly recommend making sure you know how to do this one, okay? There's another one that I missed putting on the study guide. You don't need to do it for homework, but if we have time in one of the sessions, we're going to probably want to look at it. Okay, it puts all the concepts together. It's something we've done a lot of before, but it's just, I missed getting it on the review assignment somehow. And I may have already written a question about it, so we probably want to look at it. Okay, 18. So 2 particles, P and Q, are moving along the x-axis, and just the subscript is the name of the particle. Okay, so that's what that's referring to. At selected time t's, the positions x of p and x sub q are in velocities v sub p and v sub q are given in the table above. At what time t are the 2 particles moving towards each other? Okay, so I need to know when they are moving towards each other. So I need to kind of test out the times and see what's going on. So here's how I would do that. Okay, I'm going to draw a number line. Maybe. Okay, I'm just going to examine each one of the times. So I know that at time 1, my x position is -3. I'm sorry, my p position is -3, and my q position is 4. Okay, I know that my velocity is 1, which means it's going to the right because it's positive. And my velocity is 2, which means it's going to the right because it's positive. So that time they are not moving towards each other. So it can't be time 1. Okay, I've eliminated time 1. Okay, so now let's try time 2. So again, it's process of elimination on this one. So I'm looking for where my y value is. So my position is. So P is at 5. Q is at -2. My P value is negative. So negative means I'm moving to the left. My Q velocity is negative, which means I'm moving to the left. So they're not moving towards each other. Okay, so it can't be 2. I'm going to try again. All right, so I'm trying again. Let's see, my P value is 0. My Q value is -6. All right, so I'm going to ask some questions to make sure we understood what we did on that last one. So if my velocity is negative, do I move to the left or the right? Very good. Okay, so I'm going to move to the left. Okay, so that 0 moves to the left. I should have put my P and my Q down there, huh? All right, and then if now I'm positive, so which direction do I move when my velocity is positive? To the left or to the right? Nice, okay. So do you see how my arrows pointed towards each other? So it's not a hard problem to figure out. You just got to go through the steps. It's a lot of thinking, okay? And I had to draw pictures, okay? I wouldn't have gotten it without drawing pictures. So I would say it's at t = 3. Okay? So not too bad. And I put big stars by it, right? Intent. Okay. Let's go back up to number 1. We're flipping all the way back to 1 now. Let's see, I don't have any other repeats on there. Nope. Okay, so we're going all the way back up to problem 1. Okay. It's a good old, Sir Isaac, okay, and the Newtons. So eager rock fans enter a line to buy tickets to see the renowned band Sir Isaac and the Newtons. Do you guys get the joke? What about 1? Did I miss something in that? I'm not sure I understand your question, Erica. Are we talking about problem number 1 or 1 in the last problem? Like in the last one we did. So what do you mean about 1? We eliminated 1 because they pointed the same direction. And they didn't overlap. The arrows got to point towards each other. We're looking for them to point. Wouldn't it go left? Wouldn't the 4 go left? Oh, so you're talking about t = 4? So let's look at t = 4 really quick so we can eliminate that possibility as well. So 2 is the P, 1 is the Q, positive would go right, negative would go left, so they wouldn't, it's going to 2. Like for t = 1. Okay, so for t = 1, -3. So this is the y value, and then this just tells direction. You don't put anything there. It just tells that we're going in the positive direction, so we go right. This one is going in the positive direction, so it goes right. Does that make sense? So on the velocity, you're not looking at the number, you're only looking at the sign of the number. Correct. You're just looking at the sign of the number. Okay? Make sense? Thank you for asking, because I'm sure you weren't the only one that you're welcome. Okay? All right, let's go back to the band, right? Okay, so our tunes. It is a graphing calculator question. I hope you noticed that. Okay? So eager rock fans enter a line to buy tickets to see a renowned band, Sir Isaac and the Newtons, at a rate modeled by the function given by this crazy function, 512.7 e to the negative 0.173t, where e of t is measured in people per minute. Okay, so first of all, I've seen this word rate. What does the word rate mean? Okay, derivative. So we already have the derivative of, we have the derivative function already. Okay, good. And it even tells us it's measured in people per minute. T is measured in minutes for the interval from 0 to 30. Okay. So we are supposed to find the derivative of e of 20, e prime of 22. Okay, so I'm literally going to my calculator and I'm going to plop all of this into my calculator. I have problems on another paper here. Okay, so I'm going to, do you guys know the buttons to clear your calculator? What's the buttons to clear your calculator? Do you remember? Buttons to clear. Yeah, you got Doc B. We have been listening. Nice. Okay, Doc B. All right. And then, although some of you probably learned that in my class last year, huh? Because we did start using the calculators. We didn't finish, but we did start a little bit. I don't know how far Rondo got or if Sagita got anywhere with anything. All right, so we're going to go to our graph page. And I'm going to type in 512.7. Do not type the letter E. You need to come down and use the E that's next to the 10. It's just the way the calculators work. That's the function E. And then it's negative 0.173. And then an X. I'm going to go ahead and hit enter. It doesn't matter if it shows up or not. Okay, our function's there, even though it doesn't look like anything. So now I'm going to come back to the calculator page. Okay. And we are going to do menu, calculus, numerical derivative at a point. Remember, if for some reason you don't have the graphing calculator, you may use Desmos, okay? And you would just type the function in. And then on the next line, make sure you've named the function, do E, and then the little apostrophe of T and the value. Okay, so either way is fine. All right, I'm going to type the value that I want, which was a 22. Click OK. And then I'm going to hit var F1 of X and hit enter. All right, we got the value, right? Which is going to probably earn us a point maybe on the AP test, right, to get that value. So that is negative 1.972. Okay. How would I label that? How would I label that? What's that label on that? I know it doesn't say to label it yet, but I'm curious if you know what the label is. We were a rate. It told us the rate was in people per minute, and then I just took the derivative of it. So what do you think the label is? All right, Marilyn is just suggesting people per minute per minute. So she's suggesting people per minute per minute. Or we could write that as people per minute squared. So when I made the review, I tried to do the best I could to make it as self-checking as possible for you. So that way you could check your answers as you went. It might be on the test that I don't give you all of these blanks to try to fill in and that you just have to write the sentence, okay? Which means you can write the people per minute however you want and not forced into what I had to put there, okay? All right, so let's write the sentence. What word do you think goes in here first? The blank at which people are, so remember I have to have a noun. So I'm starting with whatever, I've got to go back to the problem and find the noun. Ah, yes, that has to be the rate. Good job. The rate at which people are, let's see, rate people are entering the line. Let's see, make sure I've got that written down right. Are entering the line to buy tickets is okay, so now you have to tell me if it's in the rate is increasing or decreasing. So what do you guys think? Is it increasing or decreasing? Good, because it was negative, right? So is decreasing. And then you don't write the negative on the decimal point. You just write 1.972 because the decreasing took care of the negative. And then we label it people per minute. And I don't know if I abbreviated or not in there. I don't think I did, but I might have. Okay, and remember, I go back and I hand grade through everything anyways, so type something wrong, I will get it fixed. Okay? All right, yeah, rocking and rolling. We've done 5 whole problems in like 35 minutes-ish. That's pretty good. You'll hopefully work faster tomorrow. Remember, the best thing you can do is practice this again. Okay? Practice, practice, practice. All right, let's jump to number 4 because it's the next one you guys asked me to do. All right, so limit as x is approaching 1. What do I need to do with the 1? On the test, do we show the work that we did in the calculator on the paper? So what you should write down on the test is, actually on that one, I wouldn't expect to see much work on from the calculator because I'm going to assume you put this in and you put, and this is what I need to see is this label, which is, it's already there for you, right? And the number typed. The bulk of the points on the AP test come from this explanation. Okay, on that particular one. There's some things where we have to set things up, and I will point it out as we go, Michaela, what if it's super important that it's shown. Okay. All right, let's look at 4. So back to 4. What do I need to do with the 1? You're welcome. Plug it in, plug it in. You guys are too young for that commercial, right? I think it used to be the Glades plug-in commercial. I don't know if it was that one or if it was the Clapper commercial. I don't remember, but it was plug it in, plug it in. So we're plugging it in. So the limit as x approaches 1 of e times 1 minus e to the first over 1 square. Oh, I shouldn't be doing that. I'm doing it wrong again, right? I need to write out the thing. E to the x minus e to the x equals e times 1 minus e to the first, which would be 0. Then we're going to show the limit as x approaches 1 of 1 squared minus 1. No, it's not, Mrs. Ballard. Stop writing it wrong. X squared minus 1, then we plug in, then we say 0. So what rule do I need to apply since I have an indeterminate form? All right, good old L'Hopital, right? L'Hopital's rule. Okay, so L'Hopital, which means drew to the top, drew to the bottom. Okay, now I want you to notice something. It looks like a product rule, doesn't it? Look at this guy right here. I'm going to zoom. Okay, it looks product-y, doesn't it? It is not, because that is E is a number. It's a coefficient, so it is not a product rule. Okay, so we don't have to worry about product. We're just going to do the derivative of it. We've got the limit as x approaches 1. The derivative of e times x would just be e. Minus, what's the derivative of e to the x? Tell me that in the chat. Derivative of e to the x. We haven't practiced that one in a while. All right, it's e to the x. Excellent. Okay. And then the derivative of x squared minus 1 would just be 2x. And we're going to go ahead and plug in our 1. So we have e minus e to the first over 2 times 1, which is 0 over 2. That's okay, right? I'm allowed to have that. That's just the limit is equal to 0. Okay, that took care of problem 4. The next one I got on the list is problem 7. Zoom back out a bit. Come on. It's not going. There we go. Now it's too much. All right, so item 7. Oh, equation of the tangent line to the graph of y equals cosine x at x equals pi over 2. All right, what 2 things do we need to write? Equation of a tangent line. Put it in the chat. point in slope. That could be the t-shirt, right? You could do that, point in slope. There's our t-shirt, right? It could be the point in slope. It's a new band. All right. So P. All right, we'll adopt it. We'll see if we got to get second period on board because everybody's got to have all AB has the same shirt. Okay, we will get shirts. If nothing else, we will get shirts this year. Okay. All right, so equation tangent line. So I don't have either the point or the slope. Okay, so the I'm going to have to. How am I going to get the point? So what am I going to have to do to get the point? Not the slope, but the point. What are we going to have to do to get the point? What do you guys think? Plug in the X, and we're going to plug that into OG. I love it, Matthew. Into the original, right? Plug it into the original. Good job, Jaden. Good plug. I like the detail of the fact that we have the original. We have to have that in our brain. What's original, what's derivative. Okay? So we have to be really, I'd emphasize that a lot. Very intentionally. All right, so I'm going to rewrite it as y of pi over 2 equals cosine of pi over 2. All right, we're at unit circle. Pi over 2 is at the top. So what's the cosine of pi over 2, everybody? What's the cosine of pi over 2? Look at the, oh, I did 0. Never mind. You guys are right. It is 0. I was thinking 1. I was looking at the wrong coordinate. You guys are right. It's 0. Okay. So I was thinking it was the other one. All right. So let's now do the, how am I going to get the slope? What do I need to do to get slope? Yeah, we need to take the derivative. So we need y prime of, what's the derivative cosine? Quick. We're going to see how fast we can get our fingers typing in that chat. What's the derivative cosine? You almost can't write down what I'm doing, right? Because we're doing so much in the chat. All right, so negative sine is correct. Good job. And now I'm going to plug into there. So y prime of pi over 2 equals negative sine of pi over 2. And so the sine of pi over 2 is 1, so my slope is negative 1. So I'm going to write the equation of my tangent line. So y minus the y value 0 equals the slope negative 1 times x minus pi over 2. Likely what's happening in the y equals, the 0 goes away, and I don't remember how I typed it. If I did negative x plus pi over 2, or if I just left this. So I don't know which one I ended up with in there off the top of my head. Okay. All right. So here's where we're at. According to our list, I'm going to hit the stop record for a minute here. We have 3 more that we wanted to do. Okay. And there might be